So just a year ago, most people were asking whether AI could answer questions well. Now, the bigger question is this: can it actually help complete work from start to finish? So that shift is exactly why this topic feels so timely. In 2026, major industry reports are pointing to multi-agent systems and task-specific AI agents as one of the most important technology directions for businesses, with organizations moving beyond simple chat-style tools towards systems that can support real workflows and practical outcomes. And that brings us to this course. So this course is designed to help you understand Agentic AI and LangGraph in a way that it feels practical, clear, and approachable. You do not need to think about this as a highly technical subject meant only for specialists. Instead, think of it as learning how modern digital systems are being designed to handle tasks in a more structured, step-by-step, goal-oriented way. So this is not just a lesson about a new tool. So it is a guided introduction to a new way of thinking about digital work systems that can do more than just respond and instead help carry a task forward in an organized and meaningful way. So let's get started. So I shall quickly walk you through the agenda of this topic. Firstly, we have basics of Agentic AI and LangGraph. So we will begin by understanding what Agentic AI is and LangGraph are and why they matter, along with why they're the most useful in real-world applications. Then we have workflow design in LangGraph. Next, we will move on into workflow design concepts, including agent structure, connecting multiple agents, chaining tasks using memory and state, and improving performance through debugging and optimization. Using use cases and framework. So after that, we will look at practical use cases and compare LangGraph with other frameworks so you can understand where LangGraph fits best and it should and should not be used. Deployment and monitoring. We will then explore deployment choices, monitoring, and future-proofing useful learning tools and practical ways to stay updated in this fast-moving Agentic AI space. Then we create our first Pydantic model. Once a conceptual foundation is clear, we will move into the coding portion by creating our first Pydantic model and understanding how structured data works. Then we will add field constraints with Pydantic. From there, we will learn how to add field constraints with Pydantic so that our agent inputs follow a proper validation rule. Then we learn to handle invalid input with validation errors. We will then see how to handle invalid input using validation errors, which is very important for building reliable AI workflows. Using default values and default factory. After that, we will understand how to use default values and default factory so that the system can automatically generate and assign certain values when needed. Created nested modules for structured requests. We will also learn how to create nested models for structured requests, which helps us organize data and configuration in a more realistic way. Then we will move on to cleaning input with custom validator. Next, we will explore how to clean input using a custom validator so that messy user input can be normalized before the workflow uses it. Connecting Pydantic into a LangGraph state. Finally, we will connect Pydantic into a LangGraph state so that you can clearly understand how validated structured data flows through an agentic workflow built with LangGraph. So before we move ahead, let me share something exciting. Applied Agentic AI, Systems, Design and Impact in partnership with Simplilearn is a practitioner-level program built for professionals who want to move beyond basic AI knowledge and learn how modern intelligence systems are actually designed, structured and applied in real business settings. So this program helps you build strong expertise in multi-agent systems, RAG, MCP, workflow automation, planning systems, prompt engineering, intelligent automation, agentic UX, ethics and transparency, go-to-market strategy and product thinking. It is designed to give you both technical depth and practical understanding so you can confidently work on real-world AI systems and products. So one of the biggest strengths of this program is the hands-on learning approach. You can get real-world exposure through 40+ demos, 10+ guided practices, 7 course and projects, and 1 capstone project. So this means that you're not just learning concepts in theory, you're applying them through practical work that reflects how those systems are built and how it's used in real-world environments. So you can gain experience with 25+ widely used tools and platforms like LangChain, AutoGen, Crew AI, LangGraph, LangSmith, N8N, Figma, Miro, GitHub Copilot, Jupyter, MongoDB, Pinecone, Visual Studio, and more. So this makes the learning experience highly relevant for today's fast-changing AI and product landscape. So the program also stands out because it combines technical learning with product and strategy thinking. Along with understanding how multi-agent systems work, you also learn how to shape cutting-edge AI products, design trust-focused user expectations, evaluate metrics, and think how businesses impact and ROI. In simple words, this program is ideal for professionals who want to build real capability in modern AI systems, gain hands-on project experience, learn leading frameworks and tools, and develop the confidence to contribute to next-generation AI products and workflows. So before we move on, here's a quick quiz question. What makes agentic AI different from basic AI? So is it A, only answers questions, B, follows steps to complete tasks, C, only works with text, Or is it D, cannot use tools? Let us know your answer in the comment section below. Now we shall move on to debugging complex workflows, because once systems become more advanced, problems also become harder to spot. So multi-agent systems can create complex workflows, and when many steps are involved, even a small mistake can create a chain of errors. So some common issues include incorrect state updates, where the shared information is changed wrongly. Another issue is infinite loops, where the system keeps repeating steps and never reaches a proper end. Tool or API failures are also common, especially when workflow depends on outside services. Monitoring tools like Langsmith helps visualize execution traces, which means that they show how workflows are moved from one step to the next. So that makes it easier to identify where something went wrong. Debugging is not just about fixing errors, it's also about improving accuracy, reliability, and stability. So in real projects, this matters a lot, because a workflow that works only sometimes is not truly useful. So now that we have covered debugging, we shall now move on to ways to improve performance. So at the beginning of this section, let us talk about making these systems more efficient. So one useful tip is to reduce unnecessary model calls. So if the same kind of request is being made again and again without a good reason, that slows down things and increases cost. Another tip is to reduce caching for repeated queries. Caching helps store previous results so that the system does not have to do the same work every time. So we should also optimize token usage, because large inputs and outputs can quickly become expensive and slow. So another smart approach is to execute independent agents in parallel. So if two tasks do not depend on each other, they can run at the same time, which saves time. So and finally, it is important to monitor latency and system cost. A system may be too accurate, but if it is too slow or too costly, it becomes difficult to use at scale. Performance optimization is really about balance. So we want good quality, but we also want speed and efficiency. So now that we've learned how to improve performance, we shall move on to a few practical use cases. So now we shall move on to some direct examples of how these systems are used. Agentic AI systems are used in research assistants, where the systems can help gather, organize, and present information. They are also used in automated report generation, where information is collected, structured, and turned into reports with less manual effort. So another use case is intelligent search systems, where the goal is not just finding information, but finding the most useful information in context. Customer support automation is another major area, especially where there are many repeated questions and structured workflows. So these systems are used in code generation and debugging tools, where they support writing, checking, and improving code. So what connects all of these examples is that they involve more than one simple step. They involve sequences, checks, contexts, and actions. So now that we've explored some use cases, we shall move on to comparing LangGraph with other frameworks so we can understand where it fits best. So LangGraph is mainly suited for complex multi-agent workflows. So that is its primary strength. AutoGen is more focused on multi-agent conversations. Crew AI is known for team-based agents, where different agents work together almost like assigned roles in a team. So LangChain is commonly used for model pipelines, where the focus is on chaining tasks and building structured workflows around model interactions. So the key point here is that these frameworks are not exactly identical. Each one has a different primary use. So choosing the right one depends on what kind of system you are trying to build. So if the workflow is complex and involves multiple connected steps and agents, LangGraph becomes especially useful. So now that we have compared the frameworks, we shall move on to an equally important question: when not to use LangGraph. So at the beginning of this topic, let's remember something important. A powerful framework is not always the right answer for every situation. There are times when LangGraph may not be needed. For example, if a task requires only one model call, like I had discussed in the previous slides, then using a large workflow setup may be necessary. So if an application needs a low latency, meaning extremely fast response times, extra orchestration might become a burden. It may also not be the right fit for small prototypes or basic chatbot systems, because the setup can add more structure than the project actually needs. And finally, when the workflow orchestration itself adds unnecessary complexity, it's often better to keep things simple. So this is a very practical lesson. Good system design is not about using the biggest tool, it's about using the right tool. So now that we have understood when to not use it, we shall move on to deployment considerations. So we shall now move on to deployment, specifically cloud versus on-premise, which is an important decision in real projects. So when teams think about deployment, they usually consider factors like control, cost, security, maintenance, and speed of setup. So cloud deployment often offers flexibility and easier scaling, while on-premise deployment offers more direct control and may suit environments with strict internal requirements. At the same time, the content here also reminds us of an important caution. There are situations where LangGraph may not be needed at all, such as simple tasks requiring only one model call. Applications may need very low latency, small prototypes, or basic chatbot systems. It can also include cases where orchestration adds unnecessary complexity. So before choosing cloud or on-premise, it's equally important to ask whether the workflow truly needs this level of structure, or in other words, deployment choice matters. But the tool choice matters even more before that. So now that we've reflected on deployment and suitability, we shall now move on to monitoring agent behavior over time. We shall now move on to updates and monitoring because building the system is only one part of the work. Continuous monitoring helps maintain system reliability. So once a workflow is running, it needs to be observed regularly so issues can be caught early. So some key metrics to track include token usage because that affects both performance and cost. Latency is another important metric because people notice delays quickly. Agent decision accuracy also matters because the workflow should not just run, it should make sensible choices. Tool execution success rate is important too since outside tools and services need to work consistently for the workflow to remain stable. So tools like Langsmith provide tracing, analytics, and debugging insights which helps teams understand what the system is doing and where the improvement is needed. So monitoring is really what turns a working demo into a dependable system. Now that we have covered what monitoring is, we shall move on to making projects more future ready. Now we shall move on to future-proofing projects, which means that designing systems in a way that they can grow and adapt over time. Building scalable systems begins with designing modular agent architectures. So when each part has a clear role, the system becomes easier to expand and maintain. It is also helpful to separate agents from external tools so that the tool changes do not break the whole workflow. Another smart step is to prepare systems for new model upgrades because tools and models will continue to evolve. Monitoring and feedback loops should also be implemented so the system can be improved continuously based on real behavior. And of course, scalable infrastructure means because the growth is not only about logic, it's also about support underneath the system. Future-proofing is basically about not building something that only works today. It's about building something that can still work tomorrow. So now that we've understood how to prepare for the future, we shall move on to resources for continuous learning. So at the beginning of this section, let us look at where someone can continue learning after this presentation. Official LangGraph documentation is one of the best places to start because it explains the framework directly from the source. LangChain GitHub repositories are also useful because they show real examples and active development. AI developer communities on platforms like Discord and Reddit can help people learn through discussion and shared troubleshooting. Open source example projects are especially helpful because they let learners see how ideas work in practice. AI research blogs and technical tutorials also help by breaking down new developments and showing real-world implementations. Together, these resources help developers master agentic AI systems step by step. So the key is to not depend on just one source. Learning becomes stronger when you combine documentation, examples, communities, and hands-on exploration. So now that we have seen useful resources, we shall move on to how to stay updated in the fast-changing space. Now we shall move on to staying updated because this is an area that changes quickly. One useful habit is to follow research publications so that you can understand the field which is moving. Another is to explore GitHub repositories and open source projects because many practical ideas appear there first. So it's also important to track new frameworks and tools since the landscape keeps changing and new options appear regularly. You also need to participate in developer communities which can help you learn from real experiences and not just theory. And one of the best ways to stay updated is to experiment with hands-on projects. Stay with you. So the overall message is simple. Stay curious, stay practical, and keep learning things in small continuous steps. So let's now start off with creating our first Pydantic model. So in this topic, we're going to understand how to create our very first Pydantic model. So in this starting point, before we know how to build an agentic workflow with LangGraph, first we need to understand how structured data works. So Pydantic helps us define a clean structure for our data, and then it also validates whether the data is correct or not. So I shall now walk you through the next few lines of code. So it's from Pydantic import base model user. So let me explain what's happening over here. In the very first line, we have imported base model from Pydantic. So this is a very important line because every Pydantic model is usually created by inheriting from base model. So next I've defined a class called user. So this class represents the structure of the data I want to store. So inside the class, I have written the name str, which means the name must be a string, age, which should be an integer. So then I create an object called user and pass the actual values into it. So finally, I print the output. So let's go ahead and see how that goes. So Pydantic gave me a clean and validated structure instead of a random unorganized dictionary. So this is very useful in AI workflows because agents often pass data from one step to another, and that data should be reliable. Let's now move on to adding field constraints with Pydantic. So in this topic, we are moving one step further. So far, we only checked the type of data, but in real applications, we often need a stronger rule. For example, a query should not be too short and a priority should always stay within a certain range. So this is where field function comes into picture. So I shall now walk you through the next few lines of code. So it's from Pydantic import base model. So as you can see in the first line, I'm importing both base model and field. So we already know why base model is important. Now let's look at field. So field allows me to define extra rules for each field. So in the class agent task, I've defined a field called query, as you can see. I have defined a field called query, as you can see, and I'm saying that it must have at least 10 characters and at most 200 characters. So this is very useful because a very short query may not be very meaningful enough for an agent to process. So next, I have defined a priority as an integer, as you can see over here, and I'm saying that it should be greater than 0 and less than or equal to 5. So when I define agent type, which also has length restrictions, after this, I create a valid task object and print it. So the meaning behind this code is that Pydantic is not only checking the data type, but it's also checking business rules. So this is important in Agentic AI because every task moving through the workflow should follow a valid structure. So let's go ahead and run this. So as you can see, we've received the query and the priority as the output. Let's now move on to handling invalid input with validation errors. So in this topic, I want to show you what happens when a user gives an incorrect input. So this is one of the most important parts of the tutorial because in real-world systems, input is not always clean. Users can give short prompts, wrong numbers, or even incomplete values. So Pydantic helps us catch those issues early. So I shall now walk you through the next few lines of code. So from Pydantic import base model, finally print. So let me break down this carefully for you. So in the import line, I'm also importing validation error. So this is the error Pydantic gives us whenever the data doesn't satisfy the rules that we are defining. So then I define the same agent task model as before. So first I show a valid example so that we can see the correct input works perfectly. And then I print a message saying that I'm now testing an invalid input, as shown over here. So after that, I use a try block. So inside it, I intentionally create a bad task. So the query is too short, the priority is outside the allowed range, and the agent type is also too short. So if the input is invalid, the except block catches the validation error and then prints the full error message. So this is very useful because instead of failing silently, Pydantic tells us exactly what went wrong. So in agentic AI systems, this is a very big advantage because we want to catch errors before they move deeper into the graph. So let me go ahead and run the code. So as you can see, we have already tested the invalid inputs. Now we shall move on to using default values in default factory. So in this topic, we are going to understand how to automatically create values when the user does not provide them. So in real world AI systems, not every value needs to be manually entered. So some fields can have sensible defaults and some values like task IDs can be generated automatically. So I shall now walk you through the next few lines of code. So I shall import from UUID 4. Finally print task 2. This is fine. So now let's go ahead and understand the importance of the lines here. So in the first line, I import the UUID 4 from Python's UUID module. So this is used to generate a unique ID. Then I import base module and field from Pydantic. So inside the class agent task with defaults, I define a field called tasks ID. So this is as mentioned here. So this field uses default factory, which means a new value will be created automatically every time a new object is created. So in this case, it generates a unique ID. Then I define the query with length constraints. After that, I define priority with the default value of 1 and I define status with the default value of pending. So notice that when I create task 2, I only provide the query. So even though I did not provide task ID, priority or status, Pydantic automatically fills them in. So this is very useful in agentic AI because some workflow values should be created by the system rather than manually entering them every time. Let's now move on to creating nested models for structured requests. So in this topic, I want to show you how to move from a simple flat model to a more realistic nested structure. So in a real AI system, we usually do not work with just one small piece of data. We often have task details, model configuration, and other settings together. So that is why nested models are important. So I shall now walk you through the next few lines of code. So let me go ahead and import the from UUID. Finally, we just go ahead and print, I think it's request. So now let me explain this first. First, I've defined an agent task with defaults, which is a task structure that we already understand. Then I create another model called model config. So this is used to store model related settings. Here I have a model name and a temperature. So the temperature field has limits between 0 and 1. After that, I create a new model called agent request. So this model contains two things. One is task and the other is config. So in simple words, I'm putting one model inside of another model. So that is why it's called nested structure. So when I create a request object, I only provide the query inside the task. So when I run the code, Pydantic automatically creates the defaults for the task and also creates the default model configuration. So this can be seen over here. So this is important in agentic AI because a real workflow usually carries not just instructions but also the settings that controls how the agent should behave. Let's now move on to cleaning input with a custom validator. In this topic, we are going to see how Pydantic can do more than just validate input. It can also clean and normalize the input before the rest of the system uses it. So this is very useful because in real applications, users often type messy text with extra spaces and punctuation. I shall now walk you through the next few lines of code. So that's from Pydantic, import, base, model, we print code, task file. So let me explain the key lines of code over here. So in the import line, I'm importing field validator along with base model and field. Then I create the model validated agent task. So far it looks similar to our previous examples, but now comes the important part. So the field validator query line, this decorator tells Pydantic that I want to run custom logic on the query field. So the method clean query receives a user's raw value. So inside the method, I first remove extra spaces by splitting the text and joining it back with single spaces. So that is represented through this code. Then I check if the clean text ends with a full stop. So if it does, I remove that final full stop. Finally, I return the clean value. So when I create a good task, I intentionally provide a messy query with extra spaces and a dot at the end. So after validation, the printed output becomes clean and normalized. I'll go ahead and show that to you. So when I run the code, there seems to be an error. Let's go back and check. So as you can see, we've gotten the output. So this is very useful in agentic AI because we want to send clean input into the workflow rather than raw messy text. We shall now move on to connecting Pydantic to LangGraph state. So in this final coding topic, we will connect everything back to LangGraph. So up to now, we have seen how to define structures and validate data using Pydantic. Now we will use the idea inside a LangGraph workflow. So in LangGraph, data moves from one node to another as shared state. So if the state is clean and validated, the workflow becomes much more reliable. So I shall now walk you through the next few lines of code. So it's from Pydantic, import, base, model. Finally, we just print the output. So now let's go through this carefully because this is the part that connects Py to agentic AI with LangGraph. So in the first line, I import base model from Pydantic, and then I import state graph, start, and end from LangGraph. So next, I create a class called agent state, and this class becomes a shared state for the graph. So this contains a query, a status, and a result. So the default status is received, and the default result is an empty string. So after that, I define the first node function called validate step. So this function receives the current state, prints it, and returns an update and changes the status to validated. So then I define the second node function called the process step. So this function again receives the state, prints it, and changes to another update. So this time it changes the status to completed and creates a result message using the query. So after defining the node functions, I finally created the graph builder using the state graph agent state function. So that is as seen over here. So agent state structure as its shared state. Then I add the two nodes into the graph. Next, I connect the flow using the edges. The graph starts at start, moves to validate step, then to process step, and finally to end. After that, I compile the graph, then I invoke it by sending an initial query. Finally, I print the output, and I'll go ahead and show that to you. So the key idea here is that LangGraph allows us to move structured state through multiple steps in a workflow. So Pydantic helps us keep the state clean, and LangGraph helps us organize how it moves from one node to another. So that is the core relationship between Pydantic and agentic AI with LangGraph. So that was a full coding walkthrough. We started with a simple Pydantic model, understood how structured data works, then we added constraints using field, handled invalid outputs using validation error, created default values with default factory, built nested models for realistic request structures, cleaned user input with custom validator, and finally connected that structured data to LangGraph workflow. The major takeaway here is that we build advanced agents, tools, multi-step reasoning systems, and we need reliable data structures. So Pydantic helps us define and validate those structures, and LangGraph helps us move that structured data across different nodes in agentic workflow. So this combination is very powerful for building dependable AI systems. We've covered a very important and exciting area that's becoming more relevant across industries. What makes this topic so valuable is that it helps us understand where digital systems are heading, from simple response tools to more structured systems that can support real work in a more meaningful way. By learning Agentic AI and LangGraph, you're not just learning names or concepts. You're building an understanding of how modern workflows are being shaped and how connected tasks can be managed more effectively, and how to think more clearly when and where these systems create real value. So as this space continues to grow, the learners who stay curious, keep experimenting, and focus on practical understanding will be the ones who benefit the most. So keep exploring, keep questioning, and keep building your confidence one concept at a time. And if this course helped you understand the topic better, do share your thoughts, continue the conversation, and stay connected for more learning ahead. Keep learning with Simplilearn.